Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wasallam. Allahumma rabbi zidni ilma. Qalu subhanaka la ilma lana illa ma 'allamtana innaka antal alimul hakim. Allahumma aftah alayna hikmataka wanshur alayna rahmataka ya zal jalali wal ikram. Rabbish rahli sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Alhamdulillahi Rabbil Alameen. Ameen, Ameen, Ameen. Sallallahu Alaihi Wasallam. Ameen. Be focused. We should be focused during the lecture, especially, and we should be focused while doing anything. We should do everything with good, pure concentration. Integration Lecture 1. In this lecture, I will discuss the basic things of the integration. Let's start with the integral operator and sign of integral. Integration is the reverse process of differentiation. Therefore, to be good at integration, you must be good at with differentiation. This is known as the integral operator, and this is known as the sign of integral, and they both come together like this. And we write the function over here between the sign of integral and dx like this. Well, we remove both sign of integral and dx after integrating the function. For example, over here, this will become x cube over 3. So after integrating x cube, in fact x square, we remove both sign of integral and dx. So please remember this. Always remove the sign of integral and integral operator as soon as you integrate the function. And this is the constant of integration. We write this while integrating the indefinite integrals. Indefinite integral means integrals without limits. Well, this formula is true for all values of n except -1. When n is -1, then never use this formula. For -1, there is a different formula, and I will discuss that formula in my next lecture, hopefully. Well, this is the definite integral integration with limits are known as integration or definite integration. And this is the lower limit, whereas this is the upper limit. So in this integration, we integrate the function and we don't write c. We basically write limits here and here. So we first apply the upper limit, and then we put negative sign, and then we apply the lower limit. Basically, these are the values of x. So there are two types of integration, indefinite and definite integrals or integration. Integration without limits is known as the indefinite integration. So this integral is without limits, so this is indefinite integral. And this integral is with limits, therefore this is known as the definite integral, and this integration is known as the definite integration because this integration involves limits. So integration with limits is known as the definite integration, and integration without limits is known as the indefinite integration. We write c here and we don't write c here. Well, this is the gradient of the tangent to the curve. So by integrating this gradient, we can get y, and y is known as the equation of the curve. Well, this equation is in the form of c, they will give you some points, a point or few points to get the value of C. This is the generalized form, therefore I left this question here. So when we integrate gradient, we get equation of curve. This is very important. That is why integration is known as the reverse process of differentiation, because in differentiation, when we differentiate equation of curve, we get gradient. So in integration, when we integrate gradient, we get the equation of curve. So this is the integration and this is the differentiation. Well, this is the gradient of the tangent to the curve in the form of f prime x. You know, f prime and dy upon dx, they both mean the same thing. So while integrating this f prime x, we will get f of x, and you know how to integrate this. So this is also the equation of the curve, this in terms of C. Functions. There are 5 types of functions in our syllabus: exponential, logarithmic, algebraic, trigonometric, inverse trigonometric, and in inverse trigonometric there is only just one function in our syllabus, which is tan inverse x. So we will learn the integration of all 5 functions. So integration is the reverse process of differentiation. I already have told you this thing. The sign of integral is this. This is the sign of integral, and this is the integral operator, and they both come together. We already have discussed this thing, and this is used to integrate the given polynomials. The word integrate means use this on the polynomial, to the given polynomial. Example. Now integrate 5 minus 3x. This is the polynomial, and this word always come with polynomial. This word integrate. Whenever you find the word integrate, you need to use sign of integral and dx, and you need to write the function between these two. Make sure you write the given polynomial between the sign of integral and dx. If you won't do this, you will lose 1 mark. You cannot integrate this directly without mentioning this step. So make sure you always write this step whenever the word integrate is given. So you need to write this function in bracket, and here means between sign of integral and dx. And after that, you can integrate this function. So 5 will become 5x, and here we have power 1 of x, so it will become x square upon 2. And this is the constant of integration. Integration of simple algebraic functions. Rules. So this is the formula, in fact, x power n, and this is true for all values of n except minus 1. N can take any value except minus 1, because for minus 1 there is a different formula, and we cannot use this formula for minus 1, because if we will use this formula for minus 1, then we will get infinite, because denominator will become 0, and that will make the function infinite. So in integration, we add, this is the integration of algebraic function, so we add 1 in power and we divide function by the resultant power, and this is the constant of integration. This is the resultant power, so this power should be here. Well, when we don't have anything here, that means 1 is here, so the answer is x. or you can say that here x is x power 0. So when you will add 1 in this power, you will get, see, when you will integrate x power 0, you will get x power 0 plus 1, 0 plus 1, so x plus c. That's the logic of getting this answer. So when we don't have anything between the sign of integral, for example like this, then we always write x plus c. You can learn this as in this way, write this x. For example, if you have dy and nothing is here, just 1 is here, let's say, so the answer is y plus c. This is the way to learn this. Well, this is 5, so it will become 5x, because this 5 can be written as 5x power 0. So it will become 5x plus c. So if we have just constant, we write 5 times this variable x plus c. And here, since we don't have any function between these two, so the answer is x plus c. Well, we first simplify the function and then we integrate the function. So in this case, we first need to simplify this. For that, we need to bring x in numerator. Don't bring coefficient in numerator, only bring variable in numerator. So this is important. So when you will bring this variable x in numerator, it will become x power minus 2. And the coefficient will remain as it is. This is minus 2. So when you will integrate x minus 2, it will become minus 2 plus 1, minus 2 plus 1 plus c. So finally you will get minus 1 upon x. And since 3 upon 2 is multiplying with this, so this will become minus 3 upon 2x plus c. So make sure you only bring variable in numerator, never bring coefficient in numerator. This was the coefficient. This 3 upon 2 is the coefficient of this. So we leave coefficient as it is. We never integrate the coefficient. Again, this is the polynomial, new polynomial. So don't integrate this polynomial unless you get the simplified form of this. So since we have just one single term in denominator, so break the LCM. So the hint is break the LCM. So after breaking the LCM, you will get this thing. Make sure you will use bracket here. If you won't use bracket here, you will lose 1 mark, because the sign of integral is multiplying with both the terms, and this dx is also multiplying with both the terms. So always use bracket when we have 2 or more terms. Learn this concept. For 2 or more terms, always use bracket. Now get the simplified form of this and this as well. Here you have to bring x in numerator, x power 2. Now you can integrate this. This is the constant. So whenever you integrate constant, you write x with the constant. And we have done the integration of this x minus 2 in the last example. You know how to integrate this. Here, this is the constant. This is the simplified form of the polynomial. So we can integrate this. 1 will become x and 3x will become, since x has power 1, so this will become 3x power 2 upon 2. Here, this is simple function because the bracket has power 1. This expansion has power 1, so the function is known as simple algebraic function. This will become 1 and this will become 3x cube over 3. And this is the simplified form. So when the expansion has power 1, the function is known as the simple algebraic function. Integration of nonlinear. Integration of non-linear functions. Always expand the function first and then integrate it. This is the hint. So whenever you will find composite function, non-linear function, see, this function is non-linear. Linear function means this one. This is known as the linear function. The power of the variable is 1. I mean, function of this type, mx plus c, is known as the linear function, and functions other than this type are known as non-linear functions. So for non-linear functions, since this has power 2, and they will always give you power 2. So always expand the function first, simplify it, and then integrate it. So this is the expanded form of the function. Now you just need to integrate it, because this is the simplified form of the function as well. So 1 will become x square will become x cube upon 3, x power 4, x power 5 upon 5 plus c. Don't forget to write c. We always write c when we integrate indefinite integrals. Indefinite integral means integrals without limits. Again, this is the non-linear function. So we need to expand this expansion by using a minus b whole square. This is the simplified form, and then you can integrate it. Give your answer in this most simplified form. This is the most simplified form. Integration of composite linear algebraic function. Now this is very important. Composite linear. Linear means this type, a function of this type, mx plus c. Allah. This is the way to integrate the composite linear function. Before integrating, you need to differentiate this function. Just differentiate this mentally. When you will differentiate this, you will get ax plus b, so a. The differential of ax plus b is a. So always differentiate the function mentally first and then integrate the function by adding 1 in power. Divide the function by the resultant power and multiply this resultant power with the differential of the function. This is the differential of the function. So make sure whenever you integrate composite functions, always multiply the resultant power with the differential of the function. This is the differential of the function. This is the rule to differentiate composite linear algebraic functions. And this is true for all values of n except minus 1. Now this is the linear algebraic function. This is of this type, mx plus c. So we can easily integrate this function by adding 1 in power. So when you will add 1 in power, it will become positive half. And you need to divide function by the resultant power, because the resultant power is half, so I divided this by half. And we need to multiply this resultant power with the differential of function. Multiply this resultant power with the differential of the function, and the differential of this function is you can do this mentally, minus 3. So this minus 3 is the differential of this function. Make sure you, whenever you integrate composite function, you should multiply the function, the resultant power with the differential of the function. This is very important. And give your answer in the most simplified form. This is the most simplified form. Again, this is a linear function and its differential is negative 3. So this 3 is of the resultant power and this negative 3 is the differential of this function. But this is a non-linear function. This is not of this type, mx plus c. Since this function is not of this type, therefore we cannot use the formula of the different integration of the linear function over here. So since this function is a non-linear function, therefore first expanded and then integrated, because its differential is variable and we can never divide a function by variable differential. If you will differentiate this function mentally, you will get minus 6x. So never divide function by variable differential. Let me tell you why can't we use the rule of composite linear function onto this question. This is the wrong way. 1 minus 3x square whole power 2 is a non-linear function. So if we will use the rule of integration of linear composite function over here, we will get minus 6x here. And you know, we can never divide function by variable differential. Because of this x, this is a variable differential. Since this is a variable, so we can never divide function by variable. So this rule can never be used onto this non-linear function. So for these type of questions, make sure you always expand the bracket and then you can integrate it. And this is the wrong method because this x is variable differential. I already have explained this method over here. So whenever you get variable in denominator, then you just need to cancel your answer and do like different method to integrate the function. So make sure whenever you get variable in denominator, so cancel your solution and think about the other solution and solve the question with the other methods. Like here, you need to expand the bracket. The students are normally do careless mistakes and they don't take these things carefully, and that is why they lose their marks. They integrate non-linear functions with the same method of linear algebraic function, which is wrong, because non-linear functions has variable differentials and we can never divide function by variable. That's the logic. Well, equation of the curve from the gradient. That is why integration is known as the reverse process of differentiation, because in differentiation we get equation of curve. This is the equation of the curve, and then by differentiating this equation we get gradient of the tangent to the curve. This is the differentiation. And in integration we integrate gradient and we again get the equation of the curve. So this is the equation of the curve. This is differentiation and this is integration. In differentiation we differentiate equation of curve and get the gradient, whereas in integration we integrate gradient and then we get equation of curve. So that is why integration is known as the reverse process of differentiation. Well, this is the gradient of tangent to the curve at pxy. So we need equation of the curve. For that we need to integrate this equation, this gradient. So when we will integrate this left side we will get y, and when we will integrate this right side we will get mx, because this is constant. So whenever we constant integrate we get mx, and this is the constant of integration. Example. Well, this is the gradient of tangent to the curve at this point. This point is for C, to get C. We will use this point to get C. Find the equation of the curve. Equation of the curve means make y the subject. Get y. So when we will integrate this gradient we will get y, and when we will integrate this x minus 2 we will get x minus 1 over minus 1 plus v, and this is the simplified form. Get the simplified form first and then substitute the point. Minus 6 upon x plus c. Say equation number 1. Now substitute the point, and the point was 2, 9. Put 2, 9 into equation 1. So when you will put 2, 9 into this equation you will get C12. Now substitute back this C back into equation 1 here. So when you will substitute C back into equation 1 you will get this equation, and see, this is the equation of the curve. This is the way to get the equation of curves. You just need to integrate gradient and then you just need to substitute the point for C and then substitute C back into equation 1, and then you will easily get the equation of the curve. In differentiation we normally get this thing. So when we will differentiate this we will get 6 upon x square. This is the differentiation. And the reverse is the integration. This is the integration. Equation of curve from second derivative, one of the most important question. We need to integrate this second derivative twice to get the equation of curve, because equation of curve means y. So this is when we will integrate, well, this is the turning point, stationary point. At stationary point, gradient is 0. So by using these conditions, this is for C. In fact, we will use this point. First, we will use this to get the first constant of integration, and then we will use this. to get the second constant of integration, because we have to integrate this twice. So we will get two constants of integration. For the first constant, use this condition, and for the second constant, use this condition. So when we will integrate this on first time, we will get dy upon dx, and here we will get ax plus c. So by using this condition over here, we can easily get the value of c. So the c is minus ah. So by substituting this c into equation 1, we will get this equation. So now we have to integrate this again. Now this is the equation of the curve, and for this constant we need to use this point, and then we will easily get the constant, and then finally we will get the equation of the curve. This is the example of that concept. So this is the turning point, and you know, at turning point gradient is 0. Well, we will use this condition for the first constant and this condition for the second constant. So when we will integrate this on first time, we'll get this thing. And you know how to integrate the right side. So by substituting this thing over here, we can easily get c. This is the value of c. And this is the equation number 1. Now substitute c into equation 1. By substituting c into 1, we'll get this thing. Now when we will integrate this, we will get y, and when we will integrate right side, we'll get this thing. Now for this constant, we need to use the point S. This thing. We need to use this point, 3 minus 10. So when we will put 3 minus 10, we'll get D, and this will be the final equation of the curve. So it's very simple. You just need to integrate carefully and use the given information carefully to get the first constant and to get the second constant. Note these notations. The d2y over dx2, also known as f double prime x. This is also known as f prime x, and this is y is equal to f of x. In fact, this is integration, and when you will go in this way, that will be differentiation. Definite integrals. Definite integral means integrals with limits. And first, let me discuss the rules of definite integrals. When we have same limits, see, the limits are same. This is the lower limit and this is the upper limit. When we have same limits, then the answer will always be 0, because the limits are same. Achha, when the lower limit is greater than the upper limit, then we need to switch the limits by writing negative sign outside the integral. So whenever you will find this type of integral, always switch the limits like this and put negative sign before the sign of integral. I have mentioned this here. When the lower limit is greater than the upper limit, then we always switch the limits by writing negative sign before the sign of integral. Area. This is the application of integration. Let me write here. a most common application, area and volume. So area between the curve and the x-axis. The important thing is the x-axis. Now the first case is above the x-axis. When the curve is above the x-axis, this is the curve. When this curve is above the x-axis, no matter whether the lower limit is on second quadrant or in first quadrant, it's not an issue. The main thing is the curve is above the x-axis. So when the curve is above the x-axis, the area between the curve and x-axis can be found by using this formula. And how to learn this formula? Since x-axis is involved, so write dx, and these two are always opposite. Whenever we have dx here, this will be y. So this is the way to learn the formula. When the curve is below the x-axis, then you need to use, this is the equation of curve, and this is below the x-axis. You need area between curve and x-axis. For this area, you need to use the same formula, this formula, but you need to write negative sign before the sign of integral. Why? Because you will get this answer negative. So this is always negative, so this negative will make this positive. So that's the logic of this negative sign, because this answer will always be less than 0, and this negative will make this positive. So make sure you always write the negative sign before the sign of integral whenever the curve is below the x-axis. Area between the curve and y-axis, this is very simple. When the curve on the right side of the y-axis, this is the equation of the curve. So you just need to use the same formula, but you need to change x and y, the positions of x and y. X must be here and dy must be here. Why dy is here? Because area is bounded between curve and the y-axis. Well, this is the y-axis. dy is for y-axis because the area is bounded between the curve and y-axis. When the curve is on the left side, you just need to use this same formula, but you just need to put negative sign or write negative sign before the sign of integral, because this integral, the answer of this will be negative, and this negative will make this thing positive, because area is a scalar and it can never be negative. Area between the two curves. Now this is f of x, The upper curve is f of x and the lower curve is g of x. So to get this area, you just need to integrate the upper curve and then minus lower curve, because upper curve will give you this total area, and when you will integrate the lower curve it will give you this area, and since you need this area, so upper minus lower. Always do like this: upper curve or the curve which will give you larger area. Upper curve will always give you the larger area. Lower curve, this is the upper curve and this is the lower curve. You can take common, you can write f of x minus g of x like this as well. Volume of revolution, the second application of integration. So when f of x is rotated 360 degree about the x-axis, whether the curve is above the x-axis or below the x-axis, no problem, because it is the rotation. So we will use area formula with some changes. Like this power is 1, so in volume we change this power to 2. Replace 1 by 2 and then write pi here. So in order to learn volume formula, you just need to add pi in area formula and just change the power from 1 to 2. This is the way to learn this formula easily. And this formula can be used for when the curve is above the x-axis or below the x-axis, because volume can never be negative. Same formula is used for above and below the x-axis, because volume is never negative. When f of x is rotated 360 degree about the y-axis, use the same formula as you use in area. You just need to add 1 in power. This power will become 2. Add pi here. You need to learn these formulas. Volume of revolution between two curves is very simple: upper curve minus lower curve. So this is the area formula. For volume, you just need to add pi here and change this power 1 to 2. It's better to integrate the curves separately, because if you will use this formula, then this could make the calculation complicated. And to use this formula, you must be good at the algebra. Your algebra must be very good. To be on a safe side, try to use this formula. This is the advice for me and for everyone: be well mannered. And I will discuss the integration of these functions in my next lecture, inshallah. This is all. Wait for my next lecture. Allah Hafiz.